So integration is nothing but inverse process of differentiation. That is how we are trying to understand this process of integration itself. Okay. So if you have a function, for example, if there is a function d, what we know is dy by dx of a function is given by f dash of x. Okay. So if I want to find this function itself, what we do is we try to integrate this function with respect to dx. Then we get the actual function itself. So here the function is given, we find the derivative. In case of integration, we use this simple symbol for indefinite integrals. For now, you just remember this as indefinite integrals. We'll discuss what is definite and what is indefinite. So that's what it's mentioned here. Integral of a function is, if this is a function or some curve is given, and we're going to integrate, and we get a function plus a c. C is called constant. It's called abstract constant. Okay, which may not be clearly known to us until we do the definite integrals. Okay, so right now it's a constant. It's a random constant. Okay, so when we do integration of a given function, we get some answer that is actually antiderivative of the given function. Okay, suppose if this function is differentiated, we get this given integrand. Okay, so the function which we do integration is called integrand. Okay, and the variable, like it may be x, y, with respect to what variable we do integration, is called variable of integration. Okay, so this f dash of x, we know that is what? First derivative, right? So that is f dash of x, and this is f of x. Okay, so let's try to understand these statements with some examples. Okay, so let me read the statements first. Integration serves as an inverse process of differentiation. As I told you repeatedly, integration is nothing but inverse process of a differentiation. While differentiation involves finding a rate at which a function changes, integration focuses on determining the accumulated change, uh, a total quantity over a given interval. If you please clearly observe, in the differentiation, we try to divide a part smaller and smaller and smaller, and we try to check the rate of change at a smaller part, right? Whereas in case of integration, exact opposite. We start with a smaller part and we find the area, and we try to accumulate all this area and to find out theoretically what is the area of the bigger picture. Okay, so that is exact opposite of what we do in the integration, differentiation. Okay, in simple terms, if differentiation measures the slope of the curve, integration calculates the area under the curve. Okay, yes. So you will understand all these things in better form only when you start solving and understanding integration. Okay, so that's why we'll directly go to the examples. Where do we can see the correlation between differentiation and integration? Shall we? Yes. Say, I'm taking an example here. There is a function f dash of x is 2x. That is, derivative is given. That is, f dash of x is given as 2x. Now, can you understand for what function, what is its original function before differentiating? What was it? That is, after differentiating that particular function, f of x, I got 2x. That is f dash of x. Can you imagine what is the actual original function? Is it possible to imagine? Can you think about it? Can you please think about it? It can be x square. It can be x square, right? For example, if I differentiate dy by dx of x square, what we get is 2x, right? What if that function is dy by dx x square plus 5? Isn't it its differentiation also 2x only? Yes. What if it is dy by dx of x square plus 10? That's differentiation also 2x, because constants differentiation leads to 0 value. That is why I am not sure whether it is x square, it's x square plus 5 or x square plus 10 or x square plus some constant, whatever it is. Okay, so that constant will not be able to understand. That constant can be 0 also, it can be anything. That is the reason whenever you find an antiderivative or integrate a function, we always, if it is indefinite, That's why it's called indefinite. As we don't know definitely what is the value of this c, we call it as an indefinite integral. Okay, so that indefinite integral always ends up with a constant part. Okay, when you integrate. So hope this part is clear about what is indefinite integral. Any questions, any doubts? You're always welcome to ask me in the chat. Any doubts? Okay. So now we have to now recall our differentiation concept. Okay. So let me tell you and show you the functions which we differentiated in the last class. So we know d by dx of x power n. What is that? X power n minus 1 into n minus 1. So let me now rewrite this as d by dx of x power n plus 1 divided by n plus 1. Now what will happen to this? It will become x power n, right? So that means if I do integration with respect to this variable, we have to get this function plus a constant. Okay, that is integration of x power n dx should give you what? X power n plus 1 divided by n plus 1 plus c. So isn't it exact opposite of what we do in the differentiation? In the differentiation, we reduce that power by 1 and we multiply it by that. But in the integration, what we do? An expression of x power n format. If this is a differentiation, can you recall this? What we get? It is n into x power n minus 1. Now what are we doing? Exact opposite. We are not subtracting 1 in the power, we are adding 1 in the power, and the same number we are not going to multiply, we are going to divide by that. Okay, so that is how differentiation integration works. Because to make sure this is right form, if you integrate, if you differentiate the function we obtained here, d by dx of this, we should be able to get x power n. Are we getting? Let's see. So what happens to this is n by n plus 1 is a constant. So we can keep it as it is. N plus 1 into x power n plus 1 minus 1. So 1 cancels, n plus 1 cancels. Yes, definitely we are getting that. That means our integration process is correct. So just remember this formula then. Let me erase this. So that is integration of x power n with respect to variable x is x power n plus 1 divided by n plus 1. Similarly, we know d by dx of sin x is cos x. That means integral of cos x, cosine x, with respect to x should be equal to what? Sin x plus c. So that's plus c is because all these are indefinite integrals. Similarly, we know d by dx of cos x is what? Minus sin x. So which implies integral of sin x with respect to dx should be equal to what? Minus cos x plus c. Okay. So although even though there is a there's always a confusion, so be careful. So d by dx of tan x is secant square x. So integral of secant square x with respect to x will be tan x plus a constant, arbitrary constant. Okay, so integral of minus cosecant square x or cosecant square x should be equal to what then? Should be equal to minus cot x plus c. What is differentiation of secant x? Secant x is how much? Secant x into tan x, right? So that means if you integrate this product secant x and tan x, you should get secant x plus the arbitrary constant c. Similarly, if it is minus or if it is cosecant x into cot x, we'll be getting minus if you differentiate. If you integrate this, you will get what? Minus cot x plus c. Minus cosecant x plus c. Yes. So all these you remember, right? Now, some more examples. What is d by dx of log x? 1 by x, correct? Is it? D by dx of log x is 1 by x. That means integral of 1 by x into dx should be equal to what? Log x. So you might be thinking, sir, it's x minus 1. I'm going to apply this formula, which should give you x minus 1 plus 1 by minus 1 plus 1, which will give you x power 0 by 0, which is indefinite form. That's why we don't use this in this case. Instead, we are going to remember integral of 1 by x with respect to x is taken as log x, because differentiation of log x is equal to 1 by x. Just very simple, right? So what else we know is, we know differentiation of inverse functions, right? What is inverse of sin x? Uh, Differentiation of inverse of sin x is, can you remember, 1 by root of 1 minus x square, right? So now if I integrate 1 by root of 1 minus x square into dx, it will give you what? Sin inverse of x plus arbitrary constant. Similarly, minus 1 by root of 1 minus x square into dx should give you what? Cos inverse of x plus c. In case if I'm talking about root of 1 by x square with respect to x, it should give you what? Tan inverse of x. And these inverse functions play very, very important role in understanding some of the very what very typical integrals where it may be very difficult to solve without knowing this inverse trigonometric differentiation. Okay. I hope whatever you have seen right now so far is clear to you, so that we can move forward. Yes. Okay. So whatever I discussed right now, we have. So whichever is missed out, let me explain. So for example, what is the differentiation of exponential power e power x? That is e power x itself. That's the reason when you integrate also with respect to x, it remains as e power x plus an arbitrary constant c. So what is the differentiation of a power x? That is a power x logarithm of a to the base e plus c, right? Now, if you want to integrate a power x, so what we do is, we will again take it as a power x, but here we divide it by logarithm of a to the base e, okay, plus a constant c. That is exponential, as well as exponential with a base e and exponential function with a random base a. We always have to write this arbitrary constant unless the question says definite integrals. Okay, in case of all the other integrals which are always indefinite, we do that, and we make sure that the expression whatever we get is not something which we cannot understand or not determinate form. For example, in this case n plus 1 is there, so we have to make sure that n is never equal to minus 1. Okay. Yes. So geometrical interpretation of indefinite integrals. So let's understand the correlation of indefinite integrals in case of coordinate geometry. And just like we know, geometrical interpretation of differentiation is finding a slope of a curve, right, at any particular point. Similarly, how to interpret in difference integration process in case of real life is, if there is a function like this, we have to integrate this function, and the function is nothing but 2x dx. So yes, so if you want to integrate this function, let's keep the constant outside. It is x dx, and from the formula we know integral of x power n is equal to what? X power n plus 1 by n plus 1. Same formula if I use, my function will become x square plus c. What is this? This may be taken as y is equal to x square plus c. Can you imagine how this function looks like? What is this function? It's a function representing a parabola, right? If it is simply, if c is equal to 0, what happens? So let me erase this. If c is equal to 0, if if the integral we have integrated, we have got y is equal to x square plus c. If c is equal to 0, let me show that in the graph. It might look like, yeah. So it might look like a parabola, right? So parabola whose vertex is in origin, right? Suppose if c is not equal to 0, if c is equal to 1, what happens? It's a parabola passing through 0, 1. If c is equal to 2, what happens? It is a parabola going through 0, 2, and it keeps changing its position. But all of them belong to a same family of parabola whose axis is what? Y-axis, right? So this arbitrary constant will decide which parabola is it. Okay, so that's what is mentioned here. We know that we obtain different integral values for various values of x. Yes, different values of x. So what we finally understand from that is these integral values are similar geometrically. What do you mean by similar geometrically? All the values we got were nothing but what? Parabola. That's why they are similar geometrically. But different family members that result from varying value of c make up for indefinite integral. That is why the word indefinite, as it is not definitely one particular curve. It belongs to a family of multiple curves, and each of them are different from each other. That's why we cannot definitely say which curve is it, but we can say it belongs to a family of what? Parabola. And what kind of parabola it is? That is a parabola which is having a common axis. So like that, by not knowing C, we will not be able to understand which particular curve it is, but we know the general family of the curves for which that particular integral belongs to. Okay. Yes, I think that much introduction is enough for us about indefinite integrals. Let's try to solve some examples. Yes, so whatever I explained right now, they are given C as 1, x square plus 1, represent a parabola. Okay, so that is first y is equal to x square plus c, where c is 0, will represent a parabola with the vertex and the origin. And as you move by each and every value, so the curve will become x square plus 1, x square plus 2, x square plus 3, and so on. Okay, hence for each positive and negative values of c, each parabola of a family has a vertex along the y-axis in the positive as well as negative direction respectively. That as it depends upon which direction we are moving. So which has been shown here, we can check that for every value of c, we get a different parabola. Okay. We first understand the functions property of integration. Once you understand the property of integration, it becomes easy for us to solve more and more questions. Okay. So what are the properties we need to know is, if there is a function we have to integrate, we know that integration is nothing but what? Process of differentiation. Suppose if you know the reverse of that, we can directly use that to find the integration. For example, if you know already it is f dash of x something, and we can directly write that as its antiderivative by writing the inverse of that function. So just like the examples I gave here, for example, if I give you sine x and dx, whose differentiation is sin x? Cos. But when you differentiate cos, we get minus sign, but here we have plus sign. That's why we have to get the integration as minus cos x plus c. That is because I know differentiation of cos x is what? Cos x is equal to what? Yes, differentiation of cos x is what? Minus sin x. So whenever it is possible like this, we can do that because it is an opposite of differentiation, right? So that's what is mentioned here in this property. The process of differentiation and integration are inverse of each other in the sense of the following result. So you can check this result. Okay. Yes. Again, So we have this another example to check this. If a function f of x is given as 4x square plus 3x plus 2. So when we differentiate this function d by dx with respect to x, we get 8x plus 3. Okay. So that means when I integrate 8x plus 3, I should be getting what? With respect to x, I get 8 into x square by 2 plus 3 into x by 1 plus a constant c. This 2 will be cancelled. I end up with 4x square plus 3x, but the constant 2 here may not be understood for us because it is independent integral. Okay, but I can say definitely there is a constant that can be 0 or 1 or 2, anything. So what are we mentioning here is clearly after differentiating the original function, we obtained 8x plus 3. Then integrating, we get 4x square plus 3x, but 2 may not be there, right? Because we have got to know that is original form will not have a proper constant, so it may have the same constant, or it may be indefinitely different constants might be coming here, right? Yes. Another property to look forward and very important fact, property is two indefinite integrals with the same derivative lead to the same family of curve. What do you mean by this statement? Two indefinite integrals with the same derivative lead to the same family of curves. So, for example, if there is a function f of x which is 4x plus 3 and another function g of x which is 4x minus 7, we know very well these two functions are not same, but their integral remains same because integral of this is what? X square 4 into x square by 2, which is actually 2x square plus some constant. Similarly, plus what? So what do you see? So the functions, consider two functions that have the same derivatives. Thus, their independent integrals lead to the same family of curves. For example, this particular function only. So I am getting f of x is equal to 4x plus 3. So its derivative is nothing but 4 into constant, and uh, g of x, its derivative is also 4 into constant. For example, when you do the differentiation of this, let's forget the integration, let's talk about differentiation. When you differentiate this d by dx of 4x plus 3, I get 4, right? When I differentiate same 4x minus 7, then also I'll get a 4. There's nothing else left, right? So when we integrate, what happens? Right. When integrate, what happens is we end up with, if you take this function 4 into nothing, that is just 4. When you integrate, what happens is it's going to be 4x plus c1, right? So that c1 or c2 might be anything which is not understood again. Okay, so they will have a, that's why I'm repeating this statement again. This, they may not be asking this question, but we need to be aware of these facts so that we will not be confused in the solving problems. Okay, for example, see again, the statement I'm repeating, two indefinite integrals with the same derivatives lead to the same family of curves, and so they are equivalent. So they're called equivalent. See, this is a function 4x plus 3 and g of x 4x minus 7. But when I differentiate, I get simply similar curve with an indefinite value, because when we are differentiating, we get 4. But when we integrate it, we get 4x plus c1 and c2. Okay, it's a straight line. So it's a family of straight lines, right? With a slope of 4. Yes. So another property, sum of the integrals of two functions is sum of the integrals of given function. So if you have two different functions, if you want to integrate them separately and add them, f of x dx will give you some integral, say let's say f of x plus a constant. Similarly, integral of g dash of x with respect to x is going to give you g of x plus c. Now, if I want to add them separately, or after adding them, if I'm integrating, I should be getting the with the same variable. It should be having the same variable of integration. Then I can separately write it with a common arbitrary constant. Okay, so with an example, maybe if I have f of x is equal to 2x and g of x is equal to 3x square. If you want to integrate the first one, integral of 2x with respect to x is 2 into x square by 2 plus some constant c1. So 2 to cancels, it is x square plus 1. Similarly, integral of g of x into dx is actually 3 into x cube by 3 plus a random constant c2. If I want to do them separate together, that is 2x plus 3x square, entire thing with respect to same x. I can do it. I'll get the similar answer, but that means I get a same family of curves. That is x square plus x cube, some constant, and I can say this constant c must be equal to c1 plus c2. In that case, I can say by adding the two functions and then integrating will give you similar set of functions or equivalent functions if you add them together and integrate, or integrate them and after them adding them, it will give you the equivalent function. That is what this property says. Okay, I hope this is clear. Let's go to the next one. For any real number k, k is a constant here. It's a real number, not a variable. For any real number k, integral of that k into f of x dx. I can take the k outside as it's not a variable of integration, and I can integrate the remaining functions alone. Okay, so this is another property. And property 5 says if there are n functions f1, f2, f3, fn, and there are k1, k2, k3, like n scalars or n real numbers, and if I am integrating them with them, so I can separately take them, and you can take the k1 outside, integrate only one function. It is actually a combination of first few properties. Which property can you tell me? It's a sum of the third property, fourth property. Yes or no? Check what is third property saying. The third property says if you want to integrate a sum of the two functions, you can integrate it separately also. Same way, the fourth property says if there is a scalar or a real number multiplied to the function, I can multiply that k outside after integrating as well. So fifth property says the combination of both, sum of multiple functions with a multiple real numbers are multiplied to that. So I can simplify by taking the real numbers outside and integrating each of the functions individually and adding them. So it will give you the same result.